Hi kids, this lecture is on unit conversion, which is converting the value of a variable into different but equivalent units. It's something that you all probably do all the time on your own, but this is kind of giving you a little bit more of a template and a procedure to follow. I can tell you that this is actually one of the more important skills you're going to be learning this entire year, and I want to encourage you to try it my way. I know it's going to feel like it's slower and maybe clunkier than just doing it on your own, which you all want to do at any rate. And normally over the course of the year, I'll let you do things however you want to do them. There's not just one way to solve a problem. There's lots of ways. But in this case, I can promise you, as someone who's been there, it's going to really help you if you can learn how to do it this way. And it's not just for physics class. It actually is going to be a crucial skill for chemistry as well. So take a step back and be willing to try it a different way. Thanks. Before we get going, I want to give you a little bit of background to kind of set the table for this lecture. Some of this is math facts and things that you're probably already aware of that will come together a little bit later on. First, if you don't put units on a value, it could be anything. So in this class, we're going to put units on everything so we know what physical property it represents. Second, multiplying something by the number 1 does not change its value. So for example, 3 times 1, still 3. 5 times 1, still 5. A variable like h, whatever that is, times 1, still h. Something physical like an apple, times 1, still have your apple. So multiplying something by 1 is a pretty safe operation. Now this is where it gets interesting. There's actually lots of different ways to write 1, okay? For example, the fraction 5 over 5, that's equal to 1. So I could take that fraction into any of the math problems above, and I could say 3 times 5 over 5 is still 3. It doesn't change its value. You can even write 1 as a product, 2 plus 1 divided by 3. That's still 1. So I could substitute that fraction in anywhere above. So this is the physics part of it. An equivalency is a nifty way to write the number 1 using a fact about two objects that have different units but the same value. If you didn't follow that, it will become very clear in a second. So for example, 1 year is equivalent to 12 months. They're equal to each other. We all know there's 12 months in a year. That means that the fraction 1 year divided by 12 months is a nifty way to write 1. You can flip that fraction upside down, right? Because they're equal to each other. So 12 months over 1 year is also a way to write 1. So when we're doing our conversions, we're going to be using these equivalencies to create some funky little 1s, and then when we take those 1s and we put them into a big long math problem, they're not going to change the value, the fundamental value of the object we started with, okay? Because we can multiply by 1 as many times as we want. Okay, so if I asked you a question like how many days are there in 5 years, probably you guys are pulling out your phones, your calculators, and you're just throwing a couple numbers in there. You're doing 365 times 5, and that's great. You've gotten the right number, but in the process, you've actually violated several rules of math. So we're going to actually back up and do that same problem, but in a much longer, much more tedious, more complicated way. And I promise you, eventually you'll see why it's valuable to know how to do it this way. All right, so step 1, write down the units you are starting with on the left of your paper and the units you want to end up with on the right. So in this case, we started with years, right, 5 years, and we wanted to end with days. So we've got kind of a path from start to end, from years to days that we're trying to make. Step 2 on this problem, can you think of an equivalency that directly connects the starting and ending units, right? So many of you know that there are 365 days in a year. So that's my equivalency, and I'm going to stick it right there in the middle. 1 year is equal to 365 days. If you can't, for some reason, think of an equivalency, so if you didn't know that 1 year was 365 days, you can sometimes come up with units in between years and days that let you connect the start to the end using equivalencies that you do know. You can use as many of these intermediate steps as you want or need. So let's say we don't know that 365 days are in a year, but we do know that 1 year is equal to 12 months. So we can go from years to months. And then we know that 1 month is equal to 4 weeks, so we can go from months to weeks. And then we know that 1 week is equal to 7 days, so we can go from weeks to days. So from my start at years to my end at days, we just have a few steps in between. We're going to go through months and through weeks first. Now that we've got all of our equivalencies figured out, you're going to set up the problem. You're going to set up the math problem that we're going to do here. We're going to start by writing your starting value on the left, and then we're going to make these funky little values of 1 out of all the equivalencies as many times as we need to end up with our final units. The kind of art here is that you need to be careful about which ones you choose to use so that you can cancel out 1 unit. So for example, we'll start with 5 years. I'm going to multiply it by the first equivalency. So first we were going from months to years. And we could have chosen 12 months over 1 year, or we could have flipped that and chosen 1 year over 12 months. The reason I chose 12 months over 1 year is because this way the years is going to cancel. We've got a years on the numerator on the left and 1 on the denominator on the right. So that years is going to cancel the year on the right. If you flip it over, you end up with weird units, years squared over months or something crazy. So each equivalency that we're going to pick is designed to make the units cancel out from the equivalency before. So now we'll put in the second equivalency. We're going to go from months to weeks, so 4 weeks over 1 month. And you'll notice again, now we have a month on the top and a month on the bottom. That's going to be really useful later on. 7 days over 1 week. So again, we've got a week on the top and a week on the bottom. And the next step is just to do the math. So there's some properties of multiplication which show that you can just multiply together all of the things on the numerator and then put that line in between and then multiply together all the things in the denominator, and that's going to be equal to the fractions that we had on the left. So when we actually do this math problem, we end up with 5 years times 12 months times 4 weeks times 7 days, all divided by 1 year times 1 month times 1 week. Many of you are probably noticing that there's a few things that can be canceled out now. Because we have a year on the top and a year on the bottom, we can cancel that year. Because we have a month on the top and a month on the bottom, those cancel out too. And we have a week on the top and a week on the bottom, those cancel out as well. That's the magic in choosing really carefully which equivalencies that you use so we can cancel out all those units on the top and the bottom. And we're left with 1 unit that didn't get canceled, and that is days. So we have now 5 times 12 times 4 times 7 days, all divided by 1 times 1 times 1, which gives us 1,680 days when you simplify the math. So a quick summary of what we've done today. We did a simple math problem you guys could have solved in 20 seconds, and it only took 4 extra steps and 10 minutes longer to arrive at an answer. And it turns out the answer we came up with is probably not even quite as accurate as the one you would have gotten. So I'm sure that really feels like progress to you guys. If only I had let you take the easy way out. I do promise that I'll show you the value in this slow, clunky method at some point in class very soon. If you'd like to do one practice problem to check yourself, you could calculate how many hours are in 6 million seconds and show me in class, and I'll give you a bonus high five or something like that. Thanks.